In this lesson, we're going to walk through some examples of how to solve linear and rational equations. You should have a strong understanding of how to solve linear equations in one variable. I'm going to walk through this example and give you some steps to follow, but you really want to use the resources available to you in our course as well as in the textbook if you have any questions with solving a linear equation. So our first step for solving a linear equation would be if we had any fractions in the linear equation, we would want to get rid of those first. And the way that we get rid of those would be to multiply both sides of the equation by the lowest common denominator of all the fractions. This way, essentially, you're getting rid of your fractions, so that way you can just solve a linear equation without fractions, because most people don't like dealing with fractions. For our case, we don't have fractions, so we actually can skip that first step. Second, you'd want to use the distributive property to remove any parentheses. So this is where we are at right now. So we have negative 3x plus 5 plus 5x equals 2 times the quantity of 2x plus 3 minus 2x minus 1. So from here, we are going to then use the distributive property on the right-hand side to distribute the 2 to the 2x and the 2 to the 3. So my left-hand side is going to stay the same. So this is going to stay negative 3x plus 5 plus 5x equals, distributing the 2, we would get 4x plus 6 minus 2x minus 1. Our next step is to combine like terms on each side of the equation. So on the left-hand side, I can see that I have like terms of negative 3x and 5x. So negative 3x plus 5x would give us a 2x, and the 5 did not have a like term to combine with, so it's just going to stay plus 5. On the right-hand side, I have like terms of 4x minus 2x, which would be 2x. And then I do have like terms with our numbers of our constants of 6 minus 1, which would be a plus 5. Our next step would be to isolate the variable to one side of the equation and continue to solve for x. So right now we have 2x plus 5 equals 2x plus 5. So most people like to move your x's so that way they're on the left-hand side. It does not matter. So I'm going to move the 2x's on the right hand over to the left-hand side by doing the opposite operation. So the opposite of addition would be subtraction. So I'm subtracting the 2x, subtracting the 2x. And when we do this on the left-hand side, 2x minus 2x is actually 0. So we're just left with a 5. On the right-hand side, we moved over the 2x. That was the whole idea. So we had 2x minus 2x also cancels out. So we're just left with equals 5. So this is a unique situation where our x is actually canceled out. When this happens, we need to look at the resulting equation that we have. If the resulting equation is a true statement, then the solution would be all real numbers. So looking at what we have right now, we have a resulting equation of 5 equals 5. That's a true statement. I hope that 5 is equal to 5. As a result, we can say that our solution to this equation is all real numbers, because no matter what, 5 will always equal 5. If the resulting equation is false, say we had 5 equals 8, that's not a true statement, then it would be no solution. There is no possible value for x that I can substitute into the original that would make both sides equal to each other, versus the all real numbers, which says that I can take any value for x, plug it into both sides of the equation, and we'll always get a true statement. Even looking at what we had after our third step, where we just had that 2x plus 5 equals 2x plus 5, even from right here, I have an equation where we can see that both sides are equal to each other. And from here we can say, okay, any number that I plug in, if I plug in 1 on both sides, I would have 7 equals 7. If I plugged in 2 on both sides, I would have 9 equals 9. Any number that I plug in would always make both sides equal to each other. And as a result, that means for our problem that we just did, the answer would be all real numbers. For the next example, we're going to do a problem. We're going to solve a rational equation. A rational equation occurs when we have an x in the denominator of a fraction. So with a linear equation, we can still have fractions, but the x would not be in the denominator. It would either be in the numerator or out to the side of the fraction. So a rational equation happens when we have one x or multiple x's in our denominators of the fraction. At this point, I hope that you have a good understanding of factoring. If you don't have a good understanding of factoring, you need to go back and reread section P.5. Factoring is going to be a major component of this course, and going into this, it is assumed that you do have that as a base. So, now that we're here, our first step for solving the rational equation would be to find the lowest common denominator of all the denominators of our fraction. In order to do this, what we need to do is we need to actually factor each of our denominators. Well, the first denominator I have is x minus 4. Well, that is already fully factored. We can't factor anything else out of that. Same thing happens with our next denominator, which is x plus 2. That's going to stay. But our last denominator, this x squared minus 2x minus 8, I can factor that. So we would find what multiplies to the last and adds to the middle. So we want what multiplies to negative 8, adds to negative 2, which would just be a negative 4 and a positive 2, which means that we can factor this into x minus 4 and x plus 2. When finding your lowest common denominator, although it doesn't sound like it will be, it actually is going to be larger than you probably think. So lowest common is really the key word here, denominator. We really need to take everything unless we already have it. So my suggestion is to start with your first factored denominator. Well, our first denominator was x minus 4. This is fully factored. So in terms of our lowest common denominator, that's going to be my first factor. I'm going to keep the first x minus 4 and make that part of my lowest common denominator. I then move on to my next factored denominator, which was this x plus 2, and I go over to what I have so far for my lowest common denominator, and I say, okay, do I have an x plus 2 over here yet? Well, I don't, because I only have an x minus 4. If I don't have the x plus 2, I need to multiply it in. Okay, so right now my lowest common denominator consists of my first denominator, x minus 4, times my second denominator, x plus 2. Now looking at the last factored denominator, we have two parts. So individually, we want to go over our lowest common denominator and see if we have each factor. So in my first part of my factored x minus 4x plus 2, that came from x squared minus 2x minus 8, I would say, okay, do I have an x minus 4 already in my lowest common denominator? I do, so this is already taken care of. I don't need to multiply it in. Same thing, the next part of that factored would be x plus 2. The question would be, do I have an x plus 2 already multiplied in with my lowest common denominator? I already do, so this is taken care of, which means that your lowest common denominator of all three fractions is x minus 4, x plus 2. It is not always what happened here where it's just the number, the polynomial that we had to factor, the x squared minus 2x minus 8, that factored form happened to be our lowest common denominator. It is important that you check and make sure that each piece exists in your lowest common denominator. So the original x minus 4 is there, the original x plus 2 is there, and then the factored form x minus 4, x plus 2, those are already taken care of. Once we find our lowest common denominator, your second step would be to rewrite the equation with the factored denominator. So I'm going to keep this 1 over x minus 4 minus 5 over x plus 2, but then we want to rewrite the x squared minus 2x minus 8 as x minus 4 x plus 2. This will help you in your next step. So we found our lowest common denominator. We rewrote the equation with our factored denominator. So now we want to use that lowest common denominator by multiplying the lowest common denominator by each piece. Okay, each term, each fraction, if there's a whole number, we still need to multiply that by our lowest common denominator. Every single piece needs to get multiplied by your lowest common denominator. The reason for doing this is so that we can get rid of our fractions. All right, it's very hard to solve this without getting rid of our fractions. So that's what we're going to do. So our lowest common denominator was that x minus 4, x plus 2. So I'm going to multiply the first fraction by x minus 4, x plus 2, and I'll put it over 1 so that way you can see that we're multiplying fractions. Remember, any whole number piece we can put over 1. Then we're going to multiply our second fraction by x minus 4 times x plus 2 all over 1. And then finally, we're going to be multiplying our last fraction by x minus 4 times x plus 2 all over 1. That way we can see that we're multiplying our lowest common denominator by each individual part. From here, then, we want to actually cancel. The whole idea, again, is to get rid of our fractions. So what happens within each individual part, we're going to reduce. So I can cancel out the x minus 4 and the x minus 4. So that way we are just left with, I'm going to put that 1 that was in the numerator in front. So we have 1 times x plus 2. Same idea happens with our next grouping. Our x plus 2 would end up canceling out. So we're just left with minus the 5 from the numerator times x minus 4. And then on our other side, our x minus 4 and our x minus 4 would cancel out. And then our x plus 2 and our x plus 2 would cancel out. So we're actually just left with 6. So our result is a linear equation that we can actually now solve. Which brings us then to our next step. Our fourth step is to solve the linear equation. So following our steps for solving a linear equation, I would want to distribute to get rid of our parentheses. So I'd be left with x plus 2 minus 5x plus 20 equals 6. Combining like terms, we would have negative 4x plus 22 equals 6. Moving the 22 over, we would have negative 4x equals negative 16. And then when we divide both sides by the negative 4, we would be left with x equals 4. Now, we solved our equation, we got an answer. Okay, so there's a bunch of steps in there. We had to find our lowest common denominator. We multiplied each piece by your lowest common denominator so that we had a resulting linear equation that we can solve. The next step is the most important for our rational equations. Our last step is that we have to check. We have to check our answer in the equation. Now, anytime that we're solving an equation, we should go back and plug in, substitute into the original, and make sure that both sides are equal to each other. But for rational equations, it's imperative that at a minimum, we check whether or not our answer makes a fraction undefined. Since we're dealing with fractions, remember we cannot have a 0 in the denominator. If we get an answer that gives us a 0 in any of the denominators, that means it can't actually be a solution. You know, when we multiplied to get rid of our fractions, we sort of took advantage of the fact that there were some values that we actually can't get for x because it would not work. Our fractions would be undefined. So what we need to do is at a minimum substitute in x equals 4 into each individual fraction to see if we get a 0 in the denominator. So if we test this out, we have that answer of x equals 4. So our original equation was 1 over x minus 4 minus 5 over x plus 2 equals 6 over x squared minus 2x minus 8. So substituting in x equals 4 into each fraction, the first fraction I would have 1 over 4 minus 4. Well, 4 minus 4 is 0, so we actually right here can see that when I plug in x equals 4, I get at least one fraction where the denominator is 0. Since I got a fraction where the denominator was 0, that means x equals 4 can't be a solution because it makes the fraction undefined. So we solved for x, we got an answer, but really the answer to this problem, to the original equation, is that there is no solution because the one that we found did not end up working in terms of substituting back in. It's not. Now you can plug in x equals 4 into the remaining fractions. You'll find that 6 over x squared minus 2x minus 8 when you plug in x equals 4. That will also give you a 0 in the denominator, which will again show why it is not a solution. So make sure once you get your answer, go back, substitute in, at least just check the denominator. If it makes the denominator 0, it cannot be an answer.